And so let's keep moving forward with doing examples of these polar coordinates. And here our task is to actually, start by plotting the point. And then we're going to find two other pairs of polar coordinates at this point. Okay, so one where the r value is positive and one where the r value is negative. Okay, so let's start by plotting our axis. Our pole is here. Our polar axis is this. So pi over 3. Get a little more up. Okay, so pi over 3. And then I'm going to plot my point here, call that distance 3. So this is 3 pi over 3 in the coordinate. Okay. What are we going to use for alternatives? Well, let's start with our bigger than positive. So we're going to go pi over 3 and then just like add, oh, that's interesting, add 2 pi on. Okay, so we'll do 3 and then 2 pi plus pi over 3. What is that? 7. Second case, well, let's go this distance around. So what is that? Well, that is, we're adding on pi plus pi over 3. So that is 4 pi over 3. But we want to get ourselves flipped across the pole. And so we're going to use -3 4 pi over 3. All right. And so this was the operation that I used to get that. Sound sensible? Think you could come up with some alternate polar coordinates? All right, this is a big one. Finding the connection between polar and Cartesian coordinates. Of course there is one. Let's figure out what it is. So here is our axes. Whoa. This is our y-axis. This is our x-axis. This is also our polar axis. Here is our point. It has coordinates x, y. It also has coordinates r, theta. I'm going to draw this line. I'm going to draw this line, and I'm going to draw this line. Maybe let's make this a little clearer. This distance, that is r. This angle is theta. This should be a right angle. This distance is y, and this distance is x. Does that all sound sensible to you? Well, we've got our triangle geometry here that we can use. Okay. Well, what is the cos of theta? Cos of theta, well, that is adjacent over hypotenuse. My adjacent is x, my hypotenuse is r. What does that tell me? X is equal to r cos theta. Then similarly, sine of theta is opposite over hypotenuse. I'm using SOHCAHTOA as how I was taught. You may have a different mnemonic to remember. Y over r. Okay. We can figure out a few other things. We know that tan of theta, well, that is my opposite over adjacent, so that is y over x. And we also know that r squared is equal to x squared plus y squared by Pythagoras. Okay? And so these are our relationships that we know based on our triangular geometry. And so we can be very explicit. So going from polar 2 Cartesian. So if we have our polar coordinates, we have r and theta, we can figure out what x and y are. X, well, that is r cos theta. Y, well, that is r sine theta. If we have Cartesian and we want to go to polar, well, we have this stuff. We can figure out what r is. So r squared is equal to x squared plus y squared. And similarly, we'll have to arctan, these sort of business. But it can be done. We have the skills. All right? So let's practice with that just a little bit. So we're asked to convert the point 2 pi over 6 from polar to Cartesian coordinates. So we're in polar coordinates. We're told that we are. Let's try to draw. Pi over 6 is relatively not a huge angle, I guess. Okay. And we need to figure out what this is. So this is pi over 6. This is 2. Well, x is r cos theta, and so that is 2 cos pi over 6. Cos of pi over 6 is root 3 over 2. You can use your unit circle that you have memorized. You can use the internet. Root 3. What is y? Well, that is r sine theta. So that is 2 sine pi over 6. 2 times sine of pi over 2. Pi over 6, excuse me. It's 1/2, and that is 1. So this coordinate is 1, and this coordinate is root 3. And so my Cartesian coordinates are root 3, 1. Think you can do that on your own? All right, we're going to plot the point whose polar coordinates are 2 root 2, polar coordinates 2 root 2, and the angle is 3 pi over 4. Okay, so here we go again. 3 pi over 4. Well, what is that? It's 2 pi over 4 plus pi over 4. That is pi over 2 plus pi over 4. So I go there, that's my pi over 2, and then I go here to get my extra pi over 4. And so I'm on this ray, okay? And I'm going to use a new color and say this is distance 2 root 2 out, okay? Okay, so we have to find the Cartesian coordinates again. So x is equal to r cos theta, which is 2 root 2 cos 3 pi over 4. This turns into 2 times root 2 over 2, and I get, oh no, I lost the root 2. 2 root 2 times negative root 2 over 2. So those two cancel, and negative root 2 times negative root 2 is simply negative 2, simplifies down. Y is equal to r sine theta. I've got 2 root 2 sine 3 pi over 4. I've got 2 root 2 times root 2 over 2, and I'm left with 2. And so my Cartesian coordinates are negative 2, 2. Sound sensible? Here we go. Represent the point with Cartesian coordinates negative 1, 1 in terms of polar coordinates. So going the other way. Now we have the Cartesian coordinates and we want to get the polar coordinates. So let's plot that's negative 1, 1. There is my coordinate. I need to figure out what theta is. I need to figure out what r is. Okay. So this is going to be my theta. This distance is going to be my r. Okay, so r, we have r squared is equal to x squared plus y squared. So that is negative 1 squared plus 1 squared. I've got 1 plus 1, which gives me that r is equal to root 2. Okay. Okay, what else do I need? I need tan of theta is equal to y over x. And so that is equal to, what do I got? 1 over negative 1, which is equal to negative 1. And so there are multiple values that will do this, absolutely. We're going to take the smallest and positive, the smallest one that is positive, okay? So multiple values of theta have -1. So we pick smallest positive one, and that is theta is equal to 3 pi over 4. Okay? And so my coordinates then become, what do I got? Root 2 and 3 pi over 4. And then let's do one more here, and then we'll start a fresh set of videos, a fresh video. So here we have the Cartesian coordinates of a point given. We're asked to find the polar coordinates of this point where our r is positive and our theta goes between 0 and 2 pi. Okay, similar setup, slightly more involved because we have a negative theta. We have a point in the third quadrant, excuse me. So negative x and negative y. So here we go. So this is -2 root 3. -2, sure, okay. There's our point. We're looking for this angle, okay. Let's start with the more straightforward algebraic thing to solve, which is for r, okay. So r squared is equal to x squared plus y squared, and so that is -2 root 3 squared plus -2 squared. And so I have 4 times 3 plus 4. I got 12 plus 4 is 16. And so that tells me that r is equal to 4. Great. Okay. Tan of theta is equal to y over x. My y, well, that is -2. My x is -2 root 3. And so I have 1 over root 3. What is our smallest positive? So we're insisting that it's small and positive because we have to be in this interval from 0 to 2 pi. So smallest theta it's in quadrant 3. Okay. We know like tangent is slope, right? And so like there's absolutely coordinates that give us this in the first quadrant, okay? So so it's something to be on the watch for. So just to kind of draw a little triangle to kind of give us an idea about what's going on here. Let's look at this angle. This little alpha. Okay. If this was 2 root 3 and this is 2, well, tan of alpha is equal to 1 over root 3, and we can find the arctan function and get that alpha is equal to pi over 6. But that's actually this far, right? Pi over 6. We need to add on pi to get our proper theta. Okay, so theta is equal to pi plus alpha. Okay, so to be kind of clear, this is alpha, okay? That's what I've kind of found there. And my polar coordinates. What do I have? 4 and 7 pi over 6. All right, let's leave this video here and I'll start a new one.